Today we'll be looking at magnetic field is a region where magnetic force is being felt or experienced. But at this point, emphasis will be on magnetic field on the moving charge. Magnetic field on the moving charge. Remember, when you talk about the magnetic field, for example, you have a magnet that has assuming this is a bar magnet that has the north and the south pole. We have what we call lines of forces, like this. Lines of forces, they originate from the north pole towards the south pole. So assuming you have a magnetic material and you place it outside these lines of forces, the impact will not be felt. The magnetic force will not be felt, but when you place it within the region where the lines of forces exist, that is where the magnetic force will be experienced or will be felt. So when you are talking about the magnetic force on a moving charge, we normally express the force equals to Q VB sine theta. Assuming these are the lines of forces, and you have a force that is perpendicular to the lines of forces, then we can talk about F equal to QVB. At this point, if theta is equal to 90 degrees, it means that the force is perpendicular to the lines of forces. Then it could be another angle. Maybe it's being inclined at another angle. Maybe at that point, we'll have something like this. But if the force is parallel to the line of forces, then at that point, we can say that theta is equal to 0, and the whole of this becomes 0. So at this point, we'll now say that Q is the charge, what we call the electronic charge, V is the velocity, and B is the velocity in meters per second, charge in coulomb, and the B is the magnetic field intensity in Tesla. Theta is in degrees. So we have a problem here to solve. An electron moves with a speed of 2.0 times 10 raised to power 6 meters per second at right angles to a magnetic field of strength 0.50 Tesla. Find the force on the electron, given that the charge, or what we call the electronic charge, is given, it's a constant. So we can say that F is equal to Q VB sine theta. So at this point, we now say that Q is equal to 1.6 times 10 raised to power minus 19 coulomb, and then the V is given as 2.0 times 10 raised to power 6 meters per. And then the magnetic field strength is given as 0.50 Tesla. So we can now calculate the force by at this point, let's say at right angles. So it means that theta is equal to 90 degrees. So we can now say that force is equal to 1.6 times 10 raised to the power minus 19 times 2 times 10 raised to the power 6 times 0.5 times 0.5 sine 90 degrees. So what is sine 90 degrees? Is 1. So we have 1.6 times 10 raised to the power minus 19 times 2 times 10 raised to the power 6 times 0.5 times 1, because sine 90 is 1. So at this point, students are always tempted using calculator. So we can say that 1.6 times 2 is about 3.2 times 10 raised to the power minus 19 plus 6. Is that right? Times 0.5. So at this point, by the time we add up, we have 3.2 times 10 raised to the power minus 13. Is that right? Times 0.5. So at this point, we can evaluate this even without using the calculator. And force will be equal to 3.2 times 10 raised to the power minus 13. This is the same thing as 0.5, the same thing as half. So by the time you divide this, 3.2 by the time you divide 3.2 by 2, you'll be having F equal to 1.6 times 10 raised to the power minus 13 Newton. And that becomes the force. Find the force on the moving charge. And the force will be given as 1.6 times 10 raised to the power minus 13 Newton. If there's any question, you put it across in the comment section. Thank you.